Okay, this is the P2 paper from October 2023. This is question number 1, and this is an algebraic methods question. It's actually a proof question, proof by exhaustion. Let's have a look and see what we've got to do with this question then. It says, given that A, B, and C are integers greater than 0, okay, remember that. C is 3A plus 1, A plus B plus C is 15. Can we prove by exhaustion that the product of A, B, C is always a multiple of 4? Use the table below to illustrate the answer. Well, that's giving me a clue as to what to do then, isn't it? What I'm going to do is if I set A as being equal to 1, for example, let's do that, set A to be equal to 1, then automatically B and C will be defined. So, for example, with this one, if A is equal to 1, C is going to be 3A plus 1, 3 plus 1, so C is going to be 4. And then B will be 15 minus 1 minus 4, so B is going to be 10 there. And if that's true, A times B times C works out to be equal to 40. So that one's a multiple of 4. Good. I just keep going with setting A equal to the various values. There's going to be a reason why we can't go too many values looking at the table. So if A is equal to 2, C will be 3 lots of 2 plus 1, 6 plus 1. C is going to be 7. And then B will be 15 minus the 2 minus the 7. So that's going to be equal to 6. And then if we do 2 times 6 times 7, that works out to be 84, which again is a multiple of 4. Let's put A equal to 3 now. I'm going to get 9 plus, sorry, A is equal to 3. I'm going to get C being 9 plus 1, which is 10. So we're getting a bit of a limit here coming up. B will be 15 minus the 10 minus the 3, so that's going to be 2 there. So again, multiplying those 3 numbers together, we're going to get a total of 60, which is also in the 4 times table. And then if I set A equal to 4, then C will be 3 lots of 4 plus 1, which is going to be, sorry, C there, which is going to be 13. And then we can't get B from here. Okay, if A plus B plus C equals 15, you've already got 17 there. B would have to be equal to minus 2 here, and then they're not all integers greater than 0. So that's the limit there. What I'm going to do, just in terms of the examiner, is just explain that to the examiner. So A can only take values 1, 2, and 3. If A equals 4, then C equals 13, which leads to B equals minus 2, which is not an integer. So 44, 84, and 60 are all multiples of 4. So I've proved that by exhaustion. So yeah, in terms of the detail that you want to write down there, I think that's probably plenty of information to be able to do. It's only 3 marks, so hopefully that one makes a very different question, but one where only 3 marks, and I would have hoped most of you, even if you hadn't seen that before, would still be able to go ahead and do that one. Hopefully that all makes sense to everybody.